Hello, this is a video on TCP IP modbus with Spindle control. We'll go through the config real quick. You set up your modbus control. Sorry, let me get the right one. Set up your TCP IP modbus control. This is inputs from an 06, and this is outputs that's going to another 06. There's two of them on there. Slave address 1 for the ECOM module, 54 registers coming in, 34 going back out. And this is the start addresses at the PLC. This is start addresses of the input and output holding registers in the TCP/IP modbus for the brain. Right here on diagnostics, page 2. This is where all the Spindle control stuff is. Right here on this side. This shows what's going out on the modbus. This is the spindle speed percentage. These are counting droves that look at the macro pump. The macro pump is also integral to setting this stuff as well on initial startup. I'm going to go ahead and show you what the analog output looks like. Okay. This is the brain itself. This shows the RPM register multiplied by 4095. That's the maximum resolution of the 12-bit analog module, and this drops it into a drove for me to read here. There's another brain that sends it out to the actual PLC itself. This right here gives you an interlock on spindle clockwise and counterclockwise the LEDs. This is so you can use your M codes and your G code, and they will actually control the stuff going over your modbus. If you don't put these in when you hit M5 to cut off, your analog value stays on your modbus and doesn't shut down, which could be a safety hazard. So when both of these are off, this sends a 0 to your spindle ratio right here. I'll toggle it real quick and let you see how that works. If I do an M3 S1000, and my maximum spindle speed on this is 2000. You see here's half the value for the percentage, here's half the value going out on the modbus. This shows spindles going clockwise, output 1. If I go over here and I hit an M4, which reverses it, you're going to see it go down to 0, stop. These were all clear to 0, then it starts back accelerating the other way. Okay, and you'll see that come down, flip, and go the other way, and you see it happen flip over here in the brain as well. And this M5 right here will kill this. Now both of these are true, and you see it resets all to 0. Another part of it is the macro pump, and why that's important is because on initial startup, you have to set the start conditions if you're running everything off your serial modbus, because if you don't, it puts weird things into your spindle droves, like undefined and things of that nature. So what I did with mine on the macro pump, it shows the warnings. Here's the interlocks here. Go down here, and this is the spindle stuff right here. This shows when you first come out of the reset condition. This only runs once with the counter. Reset your spindle override. It sets your percentage to 0, and it sets your counter to 1. And then if you go and reset here and then come back out of reset, it resets this to 0, and this once again runs again to re-0 that stuff for you automatically. This stuff here is for just for diagnostic control. These outputs go out to the PLCs. The PLC sends them out to the machine, but also it reads it and sends back what output is turned on, so I know I have loop back. Like if I'm going to open a tool cover, you'll see that output 5 has opened. I'm going to close the tool cover, cuts this off, and turns on a counter hydraulic valve on the other side, and then I just cut it off. And then I'll show you what the brain control looks like on just a lot of outputs coming out. I have several brains here. This just kind of shows where your enables and all that kind of stuff is. I'm going to go ahead and shrink this back so you can see everything. And I'll put it over here. And I'll bring this window in so that we get a little bit better view. Alright. So if I disable all this, it kills all my enables. And in my macro pump, I've got for all those to cycle back on again. Usually only 1 through 3 will come on. You have to put the macro pump for 4, 5, and 6 to come on enables. For some reason, they don't come on automatically, even if they're enabled. This kind of just shows some stuff going out. You can see stuff changing as it's going out on the modbus and across the brain and into the PLC and out the output of the PLC to the machine. That's about it. Since you can't really document the brain itself, what I did is put some input-output flow charts. This, for instance, shows output mapping through the TCP/IP modbus here, and you can see that it just kind of gives you where it's going, what page, what it's doing, what its TCP/IP address is, PLC address, what it controls, what its output. So you have a second-hand documentation. That's about it. Hope you enjoyed it. Thanks. And by the way, this is Scott Papa Bear from the MOP support group.